All right, ready for today's deep dive?
Absolutely. Always ready to dive in.
Okay, well, today we're going right into the heart of the French Revolution,
Oh, wow.
but not for the reasons you might think. We're going to be looking at the life and work of Pierre-Simon de Laplace.
Huh. A scientific revolutionary.
Yeah, he was.
Sounds all right.
Yeah, and that's kind of what makes this deep dive so cool. We're not just talking about equations and theories, but we're
Mhm.
also looking at a time when science and politics were totally intertwined.
Fascinating, yeah.
It is. And our source material is pretty great. We're using excerpts from Laplace's biography
Okay.
from the National Geographic series Genios de las Matemáticas.
Sounds like a good one.
It's really good. Okay, so Laplace's story starts out almost like a fairy tale, right?
It does, yeah. Born a farmer's son in a small village, you can imagine.
Yeah.
He was practically destined for the priesthood. Can you imagine that?
Trading equations for sermons.
I know.
Quite a twist.
Definitely a twist of fate.
Yeah.
But luckily for science, his passion for math, I mean, you can't ignore that. He ended up in Paris.
Of course.
Epicenter of the
No
Enlightenment
place to be.
at the time. And this is where it gets interesting. He managed to impress one of the leading intellectuals of the day, D'Alembert,
Okay, how do you do that?
with a 4-page letter on Newtonian mechanics.
Oh, wow.
Pretty impressive.
Straight to the point.
I know. Laplace, cutting to the chase. That letter was a testament to his raw talent, even at a young age.
Yeah.
And you know what? It secured him D'Alembert's support and a professorship at the Military School of Paris at just 20 years old.
Wow.
Yeah,
So from a small village to a prestigious professorship
I know. It's amazing.
in the heart of Paris.
Amazing.
Talk about ambition.
Yeah, this really sets the stage for his extraordinary journey, doesn't it?
It really does. And his work on the stability of the solar system, I mean,
Yeah, this is groundbreaking stuff.
this is where it gets mind-blowing. Because you've got Newton's law of gravitation, super revolutionary.
Oh, yeah. Completely changed our understanding.
But it left some pretty big questions unanswered, especially about the long-term stability of our solar system.
It did. There were some real head-scratchers back then.
Like what?
Well, like the shape of the Earth itself was a hot topic.
Okay.
Newton's theory predicted a slightly flattened Earth, but some scientists were arguing for a more elongated shape.
Oh, wow.
Like, is the Earth shaped like a watermelon or a melon?
I mean, that's a pretty big difference.
Big difference.
Yeah.
And, it wasn't just the Earth. There were other mysteries, too.
What else was going on?
Well, the orbits of comets, for instance, totally unpredictable.
Oh, right.
And planets like Jupiter and Saturn were showing these weird anomalies in their movements.
Oh,
All of this was making people wonder whether the solar system was truly stable in the long run.
so how did Laplace tackle all of these cosmic puzzles? I mean, did he just chain himself to a telescope?
He was a little more proactive than that. Laplace didn't just observe. He developed incredibly powerful mathematical tools to analyze his observations.
Okay.
And what he showed was incredible. He proved that these seemingly chaotic movements were actually part of larger patterns, predictable patterns,
Oh, yeah.
that repeat over vast periods of time.
So he's basically saying that even though things look messy, there's like an underlying order.
Precisely. It was a huge victory for Newtonian mechanics, and it cemented Laplace's reputation as a scientific powerhouse.
That's amazing. But wait, there's more.
Oh, there's always more.
Because Laplace didn't stop at just explaining the dance of the planets and comets.
No.
He went even further and proposed a theory for how the entire solar system formed in the first place.
Ah, yes. The famous nebular hypothesis.
Oh, I've heard of this.
A theory that, with a few tweaks here and there, is still the bedrock of our understanding of how stars and planets form today.
Pretty impressive for a theory developed over 200 years ago.
I know.
So what's the gist? What was Laplace actually proposing?
Imagine this. A massive swirling cloud of gas and dust. A nebula, just hanging out in space.
Okay, got it.
Laplace suggested that gravity caused this cloud to slowly collapse in on itself, pulling matter inward.
Okay.
And as it contracted, the cloud began to spin faster and faster, like a figure skater pulling in their arms.
So I'm picturing a giant cosmic whirlpool.
Exactly.
Yeah.
And as this spinning cloud contracted, it eventually flattened into a disk with most of the matter concentrated at the center.
Okay.
That dense central region eventually ignited, giving birth to our sun.
Wow. So a swirling cloud of dust transforms into this perfectly ordered system.
That's the idea. And what's even more fascinating is that this was one of the first scientific explanations for the solar system's formation that didn't rely on divine intervention.
Yeah, Laplace is basically saying we can explain the universe without invoking the hand of God.
Pretty radical for the time.
No wonder he ruffled some feathers.
He definitely did. But he also inspired generations of scientists to seek natural explanations for the phenomena we observe.
That's amazing. But it wasn't just astronomy, right? Because Laplace was also a pioneer in the field of probability.
Oh, absolutely.
Like figuring out the odds of winning the lottery.
Well, sort of. But Laplace saw probability as a way to understand not just games of chance, but the very nature of knowledge and prediction. He developed something called the rule of succession.
Okay, rule of succession, what's that all about?
It's basically a way to calculate the probability of an event happening based on how many times it's happened before. Like,
Oh.
when you check the weather app before deciding whether to bring an umbrella,
Right.
that's using a simplified version of Laplace's rule of succession.
Oh, so Laplace is using math to figure out how confident we can be in things we take for granted.
Exactly. Like the sun rising tomorrow.
Right. Wow. Okay.
And this idea has huge implications. It connects to how we make decisions under uncertainty, which is something we all do every single day.
Right.
But this is where things get really interesting.
Oh, okay. I'm ready. Tell me more.
Laplace took this idea of prediction to the extreme with his famous thought experiment, the demon of Laplace.
A demon. Okay, now we're talking.
Imagine an intelligence, a hypothetical being that knows the exact position and momentum of every single particle in the universe.
Whoa, every atom, every photon, everything.
Everything.
Okay.
His question was this: if such a being existed and it had the brain power to process all that information, could it then predict the future with perfect accuracy?
So if we knew everything about the present, could we know everything about the future?
That's the question.
That's mind-boggling.
It is. And that, my friend, is the essence of determinism versus free will. It's a question that's still debated today. Do we have free will, or is everything predetermined?
Okay, I'm already feeling a little overwhelmed by all these philosophical questions.
Yeah, I think it can be a lot.
But, I mean, if this demon was real,
Right.
wouldn't that mean free will is just an illusion? Like we're all just puppets,
Yeah.
on strings?
It's one way to look at it. And Laplace, a staunch determinist himself, seemed to think so too.
Okay.
He believed the universe operated like a perfectly tuned machine, governed by these fixed, unbreakable laws.
Right.
And in theory, if we had enough knowledge, enough computing power, everything could be predicted.
Wow, everything.
From the fall of an apple to the rise and fall of empires.
I don't know, that feels a bit too neat and tidy, doesn't it?
Yeah.
I mean, isn't the universe full of surprises? What about random events, chance encounters, just the general unpredictability of human behavior?
You're absolutely right to question that.
I think, yeah.
Modern science has shown that Laplace's deterministic worldview was, well, a bit too simplistic. The development of chaos theory in the 20th century really changed things. It showed that even in systems that are governed by those deterministic laws, tiny uncertainties in the initial conditions can lead to wildly different outcomes over time.
So even if this demon had access to all the data, it still couldn't predict the future perfectly.
Exactly, because even the smallest error in measurement could throw everything off.
Okay, so chaos theory sort of saves us from determinism then.
In a way, yes. It introduces this element of unpredictability, even in a seemingly ordered universe.
Oh, okay. But then what does all this mean for free will? I mean, if a super intelligent demon can't perfectly predict the future,
Right.
does that mean we actually have the freedom to choose our own path?
Now you're asking the million-dollar question. That's what philosophers are still debating today.
So it's like Laplace, with this thought experiment,
Uh-huh.
really opened up this whole Pandora's box
That's
of
exciting.
philosophical questions.
It really is incredible how one thought experiment can spark such long-lasting debates. And even though Laplace's deterministic view has been challenged, his demon still makes us think critically about the limits of our knowledge, the nature of prediction, and what it truly means to exist in this universe that's both orderly and unpredictable.
Okay, so we've covered a lot. From a small village in France to the farthest reaches of the cosmos. From the stability of the solar system to free will.
Yeah, we've been all over the place.
We have. But there's another part of Laplace's story that we haven't touched on yet. His role as a builder, not just of theories,
Right.
but of the institutions that shaped the future of science itself.
Ah, yes. Laplace wasn't just this brilliant mind working in isolation. He was deeply involved in creating structures that would support scientific research for generations to come.
So he wasn't just solving equations, but actually building the platform for future scientists to do the same.
Exactly. And one of his most significant contributions was his involvement in the establishment of the École Polytechnique in Paris.
The École Polytechnique, I've heard of it, but my French educational history is a little rusty.
Yeah, it goes way back.
What's so special about this school?
Well, it's one of the most prestigious scientific and engineering schools in the world, even today. And it played a crucial role in shaping French science and technology in the 19th century. Its influence is still felt today.
Wow, so how did Laplace get involved in all of this?
Well, remember that Laplace lived through a period of intense political and social upheaval, right? The French Revolution had just swept away the old order.
Right, yeah.
And there was this huge push to create new institutions that embodied the ideals of the revolution.
Like reason, progress.
Exactly. The advancement of knowledge. These were the pillars of this new society.
So the École Polytechnique was part of this vision for a new France, a nation powered by science and reason.
Precisely. Founded in 1794 during the Revolution.
Wow.
It was a bold experiment. Its founders, including Laplace, envisioned a truly elite institution to train the best and brightest minds to become the scientists, engineers, and military leaders of the new republic.
It sounds like a scientific boot camp for the future of France.
I like that, a scientific boot camp.
Yeah.
And Laplace had a very specific vision for the curriculum
Oh, yeah.
and teaching methods at the school. He was a big advocate for rigorous, mathematically based education, one that emphasized theoretical understanding and practical application.
So it wasn't just about memorizing formulas, but actually equipping students to solve real-world problems using math.
Exactly. That focus on bridging theory and practice became a hallmark of the École Polytechnique
Wow.
and played a huge role in its reputation for innovation and scientific excellence.
So Laplace wasn't just shaping the minds of individual students, but he was shaping the structure of scientific education in France, which then influenced the future of the nation itself.
His impact was definitely far-reaching. Graduates of the École Polytechnique went on to make incredible contributions in so many fields. They helped build modern France bridges, roads, telegraphs, weapon systems.
It's amazing how Laplace's influence went way beyond abstract theories. It really shaped the world around him.
It really did. And his vision of a scientifically literate society, a society driven by reason and the pursuit of knowledge, I mean, that still resonates today.
Yeah, I can see that.
The École Polytechnique stands as a testament to his legacy, a concrete embodiment of his belief in the power of education.
Okay, so we've explored his groundbreaking work in astronomy, his adventures in probability, and his impact on scientific institutions. But now I'm curious about the man himself. What was his personal life like? Was he as serious in his personal life as he was in his scientific pursuits?
That's a great question. And it's one that historians have been trying to answer for years,
Right.
piecing together the limited personal records that we have.
Right.
But what we do know is that Laplace married Marie Charlotte de Cordy de Romange in 1788.
Okay.
She came from a noble family, which definitely helped elevate his social standing.
So he was climbing the social ladder as well as the intellectual one?
It seems so.
Uh.
And they had 2 children together, a son, Charles Emile, who actually followed in his father's footsteps and became a general and a senator.
Oh, wow.
And they also had a daughter, Sophie Suzanne, who sadly died in childbirth.
Oh, that's heartbreaking.
Yeah, it is. But, you can find these little hints in his writings about the importance he placed on family
Oh, right.
and personal connections. For instance, in his Essai philosophique sur les probabilités, he talks about applying probabilistic reasoning to questions of morality and social justice.
Wow. So he wasn't just this cold, calculating mathematician. He was thinking about ethics and applying scientific thinking to moral questions.
Exactly. It suggests his personal values and experiences really influenced his work, just like his scientific work shaped his views on society and human behavior.
He was a complex figure, wasn't he? A man of intellect, but also compassion.
He was.
Okay, so we know he was a brilliant scientist, a builder of institutions, a husband, a father. But what about his religious views? I mean, we talked about the demon, which seems to challenge those traditional notions of God. Was Laplace an atheist?
That's a question that's been debated by scholars for a long time. Remember, Laplace lived during a time of incredible intellectual change.
Right.
Traditional religious beliefs were being challenged by these rising Enlightenment ideals.
Yeah, with reason and observation.
Exactly. And Laplace's work, his theories about the solar system,
Yeah.
seemed to offer natural explanations for things that were previously attributed to God.
Right, it's like he was explaining the universe without needing God in the equation.
That's how it seemed to many. And there's this famous anecdote. Maybe it's true, maybe not.
Okay.
But it's about Laplace presenting his work, Mécanique Céleste, to Napoleon.
Oh, wow, okay.
Napoleon, after looking it over, asked, Monsieur Laplace, they tell me you have written this large book on the system of the universe and have never even mentioned its creator.
Ooh, that's a tough one.
It is. How do you respond to that?
Yeah.
But Laplace, according to the story, replied simply, Sire, I had no need of that hypothesis.
Wow. That's a bold statement.
It is. It really captures the essence of Laplace's scientific approach.
Right.
He was looking for explanations rooted in natural laws, mathematical principles,
Yeah.
not supernatural forces.
Okay, so he was a man of science, first and foremost. But can we definitively say he was an atheist?
It's more complicated than that,
Mm.
you know. Religious belief was complex back then. There were a lot of different views coexisting.
So it's possible he held some personal beliefs even while taking this purely scientific approach.
It's definitely possible. Some scholars argue that his determinism, his belief in the universe operating under faith laws, could even be seen as a kind of secular faith.
Oh, that's interesting.
Yeah.
So even if he didn't believe in a personal God, he might have still felt awe for the order of the universe, replacing traditional faith with a kind of scientific faith.
That's one way to look at it. We may never know the full extent of his religious beliefs, but what's certain is that he was incredibly intelligent and dared to challenge conventional thinking about the universe and our place in it.
Okay, so we've covered his achievements in astronomy, his impact on institutions, his personal life, his religious views, but we haven't even touched on his contributions to mathematics.
Oh, you're right. He made significant advances in calculus, differential equations, potential theory. He was a master of mathematical tools.
It sounds like he was a key figure in that scientific revolution happening alongside the French Revolution, a revolution that transformed not just science, but the whole world.
Absolutely. He didn't just contribute to the existing body of knowledge, he helped change the way science was done. His emphasis on mathematical analysis, on precise measurements, that continues to influence us today.
It's fascinating how his work was so tied to the political and social upheaval of his time. It wasn't just theoretical. He was shaping science in a world that was changing dramatically.
And that's what makes his story so interesting, right? He was a product of his time, but also transcended it.
Yeah.
He lived through the fall of the monarchy, the rise of Napoleon, and the restoration of the Bourbons. And through all of that, he remained a leader in French science, serving in government, guiding research.
It puts our modern scientific debates into perspective.
It does, doesn't it? It's a good reminder that science never exists in a vacuum.
So true. We've covered so much, from the stability of the solar system, the origins of the planets, the math of probability, to even the education of scientists. Laplace's influence is everywhere.
It really is. And while some of his specific ideas have been challenged or refined over the years, his impact on science and mathematics is undeniable. He helped bring about a new era of scientific inquiry,
Yeah.
one that was defined by rigor, precision, and a willingness to question the status quo.
It's pretty amazing that even over 200 years later, Laplace's work is still so relevant.
It really is. He reminds us that, the pursuit of knowledge is never ending. Always questioning, always exploring, always pushing the boundaries.
And that journey, just like the universe itself, is full of, wonder and mystery.
Oh, absolutely.
And possibility.
Endless possibility.
And speaking of journeys, we've talked about Laplace's influence on astronomy, probability, mathematics, even the way science is organized.
Right.
But did you know he also explored chemistry?
Oh, yeah, he did.
Seriously.
He couldn't resist, especially at a time when chemistry was undergoing its own revolution.
So while telescopes were on the stars, test tubes were bubbling away in the labs, and Laplace had to be right in the middle of it all.
He had to be. And you know what? He actually teamed up with Antoine Lavoisier, the father of modern chemistry.
Oh, Lavoisier. Yeah, I've heard that name.
Yeah.
Wasn't he the one who, figured out oxygen?
That's the one. Lavoisier was a true pioneer. Not only did he identify oxygen,
Yeah.
he helped dismantle that old phlogiston theory.
Oh, right, which was holding back the understanding of combustion for so long.
For centuries.
So it sounds like chemistry was going through a huge shift, just like astronomy was with Laplace and the solar system.
Absolutely, a time of massive change.
A real intellectual upheaval in all areas of science.
It really was. And Laplace, with his talent for applying math to problems,
Yeah.
he saw a chance to contribute to this chemistry revolution.
So how did this scientific dream team end up working together?
Well, they were both members of the Academy of Sciences,
Right.
so their paths would have crossed often. But more importantly,
Yeah.
they were both committed to using quantitative methods in science. They believed in measuring, analyzing, and finding those mathematical relationships in nature.
So they were united by their love of numbers
Yeah.
and their drive to kind of crack the code of the universe, whether it was in the stars or chemical reactions.
Exactly. And their collaboration led to some fascinating research, especially in their study of heat.
Heat. I thought we were talking chemistry.
We are, but back then, heat, or caloric as they called it, was thought to be a key element in chemical reactions.
Okay.
Remember, this was before we understood thermodynamics.
Right, right. So they were trying to understand this caloric and how it affected how elements combined and reacted?
Exactly. They used a very sophisticated ice calorimeter to measure the heat absorbed or released during reactions, really trying to make sense of it all.
They were really putting heat on trial, huh?
They were. And their work helped establish the idea of specific heat, which we still use today.
Oh, wow.
It's a small detail, but it was a step toward a more quantitative understanding of chemistry.
So Laplace wasn't limited to astronomy, math, or scientific institutions. He was a pioneer in chemistry, too.
A true force of nature. And even though his work in chemistry might not be as famous as his other accomplishments, it shows just how versatile and curious he was.
It really does. So as we wrap up this deep dive, it's clear that Pierre-Simon de Laplace was much more than just a mathematician or astronomer.
Oh,
A
absolutely.
true polymath, a scientific revolutionary.
He left his mark on everything he touched.
He helped us understand the solar system, he gave us new mathematical tools, he changed science education, and even contributed to the transformation of chemistry. His influence is all over science, even today.
It really is. What I find most inspiring is that he represents that spirit of constant questioning, that deep belief in the power of reason to help us understand the universe.
Yeah, definitely.
He's an example of what we can achieve when brilliance meets dedication, curiosity, and ambition.
And his story is a reminder that the search for knowledge is a
Absolutely.
journey that unfolds with every new discovery.
A journey that we're all a part of, whether we're scientists or just curious people who want to explore the universe.
Exactly. And I think Laplace, with his own curiosity and belief in science, would be thrilled to know that his work still inspires us to ask questions, find answers, and keep pushing those boundaries.
I think so too.
So to everyone listening, keep exploring, keep questioning, keep pushing. Laplace's spirit lives on in us as we explore this amazing universe.
What a great way to put it.
Well, that brings us to the end of our deep dive into the life and work of Pierre-Simon de Laplace. We hope you enjoyed this journey through the history of science and the power of human curiosity.
Until next time, stay curious and never stop asking those big questions.